happened about 13,000 years ago. Joining us this morning to tell us about these new findings regarding what might have happened and how those findings are being interpreted are Luann Becker, who is an associate researcher with the Institute for Crustal Studies at the University of California in Santa Barbara, Alan West, who is with Geoscience Consulting in Dewey, Arizona, Richard Firestone, who is a staff scientist at Lawrence Berkeley Laboratory in Berkeley, California, and Professor James Kennett of the Department of Earth Sciences at the University of California in Santa Barbara. Starting with Dr. Firestone, I believe. We'll have each speaker give a presentation of about 5 minutes. And because of the number of panelists up here this morning, I ask that you please keep your remarks brief. When all the speakers are finished, we'll open the floor to questions from members of the press.
Yeah, that's fine.
Thank you all for coming. We're talking about something I think is pretty exciting, at least to me, I hope to you as well, about an impact that we have found evidence for that occurred about 12,900 years ago, give or take 100 years or so. So I'm Rick Firestone, and Alan West will talk in a bit. I did a lot of chemistry on this, and I've been involved in this project for about 8 years, 9 years, with a fellow named Bill Topping, who really started me on this, and is still involved. Alan was our field man, got out there and took all the samples and dug in the dirt and figured out how to find a lot. Can you hear this? I guess. Okay, anyhow, Alan got a lot of the samples that we have studied and has figured out an awful lot of not only how to analyze these samples, but how to understand these samples. He's an encyclopedia of information. Jim Kennett got involved in this later on. He'll explain to you why this is important to the world and the Younger Dryas. And Luann Becker, who also got involved more recently, will tell you a lot of interesting stories about fullerenes and carbon that we find in these samples. So this is not the event. There were no cameras there at the time. Okay, so we went to many sites and around the country. These are the research sites that we studied, including one in Belgium. You can see there's a wide range of sites we studied. All of these sites are related to a particular time frame, either by the existence of Clovis material or a black mat, which is found at many of these sites. You can see the black mat here at a site called Murray Springs. This black mat actually conforms over fossils that are found at this site of extinct mammoths. And after 12,900, which is the start of this black mat, which actually is very dark here but continues up much higher, there are no evidence of any more mammoths or Clovis people or anything from that era. It appears that this is a fine line that separates past events and future events. And inside this line, between the fossils and the black mat, we find a layer that I would call an ejecta layer. That is available at all of these sites. And I'll tell you a few of the things we find in this layer. We find something called microspherules. These are metallic spherules. If they all look the same, it's because they are essentially all the same. We find a lot of magnetic grains as well. These are separated magnetically. Alan will tell you about how we get some of these samples out of the mat. So this is a traditional ejecta layer. Many of these have been seen in the past. This is a different ejecta layer because the chemistry is different. I'll go into that in a little bit. But it is basically, the microspherules don't have any way of being produced, at least in quantity, across such a large area except by an impact. We find something unusual called carbon spherules. The carbon spherules are vesicular. They have all little cellular holes in them. They contain nothing but carbon and water, essentially. The carbon spherules also contain nanodiamonds. That's another thing that comes from space, not from Earth. We find glass-like carbon, these things that look like melted pieces of taffy, carbon that has been heated so hot that it melted and became glassy. And these also have nanodiamonds in it. And as Luann will tell you, they have fullerenes in it. And the fullerenes are enriched in helium-3, which is a rare isotope of helium, which is abundant in outer space, but not on Earth. We have other unusual things. Of course, we have soot, we have charcoal. Those are more common things, probably from very intense fires. And we have copal or amber, depending on what you call it, spherules that we find in these sites. We don't know why they're there, but they're also associated with these events. So these things tend to be found at all the sites. Alan will give you more information about exactly what we find. And we find this unusual chemistry. This is the first time that prompt gamma activation analysis has been used to analyze meteoritics. It's a relatively new method of analysis that's sensitive to all elements. And I do this in Budapest. I've done this for many years in Budapest. We also use traditional neutron activation analysis. And so we've analyzed these ejecta layers, and one of the things we find is excess iridium concentrations. We don't know for sure how high they are. They seem to be quite a bit higher than terrestrial backgrounds. Iridium is a marker for extraterrestrial impacts. We also find high titanium concentrations. That's never been seen before, but we find this in both the microspherals and the ejecta itself. This is common throughout this layer. It's something new. We think probably this is a comet. Nobody knows what's in the middle of a comet, and this may be what's in at least some comets. We find excess of the isotope potassium-40. That can only happen in space. It's been seen in meteorites. It's not seen on Earth. Potassium-40's abundance on Earth is constant, but in our samples, it's elevated. And so the composition of the ejecta layer is very different from the Earth's crust. In fact, the only thing we could find similar to it is the lunar procellarum creep. This is the sediments that were brought back by the Apollo astronauts. And it's a very small part of the moon, and it has similar chemistry. Now, I'm not going to say that this meteor came from the moon, but it's an extraordinary coincidence that it has this, that this is the only thing we've been able to find that's at all similar to the material we find in this ejecta layer, at least the metallic material. Okay, so basically our conclusions are that there was a major impact that occurred over North America. It most likely caused megafaunal extinctions and the onset of the Younger Dryas cooling. These are things that Jim will tell you more about, but these are all coincident to the impact event. And we think that the impact is most likely an airburst over the ice sheet near the Great Lakes, and that may have destroyed the ice sheet and created the Younger Dryas and other associated events. Now, in some sense, an airburst is similar to what happened in Tunguska. Some of you may know that event in 1908, where it destroyed 2,000 square kilometers of Russian forest and was seen all over Europe. Now, the impactor we think is a comet, but like I said, it's remarkably similar to material from the moon, so there's a big mystery there of what it is, and we see the soot and charcoal, so we know there were massive fires. These fires and the dust from the event probably caused a large fraction of the cooling that occurred after this event. Earth was warming, and then it suddenly went back into a cooling period, the Younger Dryas, for 1,000 years, and the real question is this going to happen again? How important is this to our understanding of climate in general? So I'll turn this over to Alan, and maybe we'll just switch seats.
This is a little different map of what Rick just showed that indicates the extent of the event. I think that's one of the unusual things that we found is how widespread this was. You can see that the first sampling that we took was in Michigan, but by the time we were through, we had gone into Alberta, northern part of Alberta, around Edmonton, 3 sites up in Alberta, 1 in Manitoba, several in offshore California, 1 in Arizona, 1 in New Mexico, quite a few in the Carolinas. And then furthest reach was all the way to Belgium. Now, we don't know whether the event covered that complete area or not, or whether this was just part of the plume, but at any rate, we do find these markers, these cosmic markers, at every one of the spots where these dots are, and we have found some of them as far away as Belgium. One of the main sites that we looked at was called Blackwater Draw, and Blackwater Draw is what's called the type site for the Clovis point. And those are 4 or 5 Clovis points that were found right at Blackwater. And you can see, if for those of you not familiar, the Clovis point has a very distinct flute down them that makes them look quite a bit different from most other points, not all, but it is a distinctive type of manufacture. This is a picture of actual excavation at Blackwater, where the impact layer that we find is right where they're working and where all of these points came from. When the points are found, the impact layer is invariably mixed in with them or above them, and these points are never found above it, and the mammoth bones and all the points or the parts of the mammoth are never found above it either. So while it may be coincidental, it seems awfully coincidental that the mammoths disappeared at exactly the same time we find this impact evidence. This shows some of what we found at Blackwater, and this is what we call the black mat. This is a fairly distinctive layer that's at many sites, and it's when it's there, it's invariably above the impact layer. So right at the bottom, where the tip of that arrow is where we find the pictures that you saw, the microspherules, the iridium, the fullerenes, the helium-3, excess helium-3, all the markers that we find, and there are 11 of them, we find right at that point. Not all sites have all of them, but all sites have some of them. In fact, we've never found a site yet that did not have some of these markers, and we've looked across parts of 2 continents. Okay, this shows that the magnetic grains and the magnetic spherules have a very distinctive peak right in this area where all the Clovis points were found. And by the way, the Clovis occupation was just a thin part of this layer. They were not in the continent down here as far as we can tell, and they were gone. Their technology was gone up here, so they were only available, or that is, their points are only found where these peaks are. We also found at this site excess iridium above background and a form of glass-like carbon. We've looked at 26 sites altogether currently, and this is a bar graph of what we found of the magnetic spherules. You can see it varies. We've currently studied 15 sites for magnetic spherules. That is, we've looked. We haven't looked at all of the sites. So it's well above 80% of the sites have magnetic spherules. All of the sites have magnetic grains. Iridium's at the majority. As we go down the list, carbon spherules, the vast majority of the sites. Glass-like carbon currently is at all of the sites. And the other new discovery is we found nanodiamonds at 3 of the 4 sites, and they are in this carbon-like product. So we don't know how widespread they are. We only know now that there are 3 of the 4 sites, but we're finding them just about everywhere we looked. The fullerenes have been found at all 4 of the sites, and Luann will talk about that further. But everywhere we look for fullerenes and excess helium-3, it's been there. Collectively, charcoal, soot, and PAWs, which are a particular form of carbon product that indicates intense fires, we found those at 22 of the 24 sites. So you can see all in all that at 75+% of the sites, we find these markers. Okay, so what caused it? There's a lot that we don't know. What we do know is there's no smoking hole in the ground, which would be typical of the KT impact. So we're almost certain this was not an asteroid. It wasn't a giant rock. It wasn't a giant nickel iron body that came in, because they typically leave big holes. What this was probably like Shoemaker-Levy. It was a fragmented comet. And Shoemaker-Levy had 19 major fragments when it hit Jupiter. And if those fragments had hit Earth, according to NASA calculations, not a one of them would have left a crater. They would have exploded in the atmosphere. All 19 of those, if they had hit Earth, would have been a succession of 19 massive explosions in the atmosphere. And while they would have been devastating, there would have been no holes in the ground from any of them. So here we have an animation that's from National Geographic that shows what it may have been like. This shows over Northeast or Southeast Asia an animation of a fireball event 750,000 years ago that we think was somewhat similar to this one. And as you can see, there were 6 or 7 objects that came in with this. That event left no crater either that they've been able to find. And yet you could see it formed a canopy of fire that, for all practical purposes, would have been a fast broil for everything under it in Southeast Asia. We think a similar thing happened for this event. Now, Jim, Kennett, going to do the next part, or was Luann going to do the next part?
I don't know.
She'll take a shot.
Well, okay, I didn't bring anything with me today. I just want to say that we have been looking at other types of extraterrestrial tracers, and most of you who follow my work know that I've been looking at fullerenes with extraterrestrial noble gases trapped inside. The interesting thing about this to me when I first got involved was the fact that there was so much carbon in this layer. And it certainly did lead to my thinking that it was certainly worth a shot to try and see if there was any fullerenes, and in particular also try to advance some of the earlier evidence, which was mainly spherules and certainly unusual carbon, glassy carbon and so forth, but also try to couple that with the traditional types of impact tracers that we look to when we think about trying to say something about an impact event in the geologic record. And that was, of course, the work with the iridium, which I think is a real coup, because everyone knows that iridium was the quintessential marker for establishing that there was an impact event 65 million years ago. And so that was really a kind of nice finding. Of course, we wanted to go in and look at the possibility of fullerenes. There are fullerenes, unquestionably. We do find some variability in the abundances of the gases in the fullerenes. I think it has something to do with the preservation, and I'll talk more about that tomorrow. But clearly we do have a signature which we believe is part of the actual impact event. It's not something that forms as a function of the impact. It's clearly a direct line of evidence that this was at least carbon-bearing, whatever it was, whether it was a comet or some smaller asteroid body, I think is open to some more investigation. And clearly the other thing, of course, is the new results on the nanodiamonds. Now, one thing that we've been doing as a group in my own work was to start and to establish that we can also see fullerenes. Now, tomorrow I'm going to show you some figures of what fullerenes look like using a TEM, just like you're going to see some pictures probably of nanodiamonds. And I think that clearly they're very distinctive and very things that we can actually differentiate between. And there's nothing like being able to see something. So it really is clearly a step in the right direction. And is hopefully the other thing that I think is very interesting about this event and ties very nicely to other events like the KT is soot. There's no question there were fires. Fires probably were initiated, but also were carried into subsequent changes in the ecosystems that clearly affected the animals and even the people. And so the fire, the soot, certainly looks very much like a KT event. I think this is the first time Wendy Wolbach and I have collaborated a little bit on this. She tells me this is the first time that she's seen real good definitive evidence for wildfires associated with an impact event. And she's looked at a number of other events just like I had, like the Permian. You don't see fire at the Permian, but clearly we see it here. And it's something that is found, as Alan mentioned, across the board. So I think the combination of the variety of lines of evidence that you'll see tomorrow in our presentations is a strong indication that clearly there was an extraterrestrial event. Now, tying it to all these other types of coinciding, contemporaneous, however you want to put it, changes in climate, changes in the ecosystem, and hydrologic changes across North America are extremely intriguing and very important to understanding just what role, if any, impacts play with respect to climate and maybe even influencing what happens to animals that are around at that time. So it does tie very nicely together. I think we have a good story to tell you, and I hope you all show up tomorrow and we'll show you all of our evidence.
Okay. The first thing I'd like to say is that I've worked on a lot of things in my career, and I find this extremely exciting to work on this project. and as challenging as it is. And I got to say that it's a real privilege to work in this program with this group of people. And the group, there's a wide group of individuals who contributed to this project. I mean, there were 22 abstracts in the session. I think over 75% of them are presenting data in support or in general or consistent with these various hypotheses that are being put forward, and evidence for the extraterrestrial impact of 12.9. There's several on the order. Douglas Kennett, my son, is an archaeologist. John Johnson, who will be presenting tomorrow. Archaeologists. Douglas said he's willing to answer questions of any of you in terms of the cultural aspects he'll be talking about tomorrow. In other words, the effect on the potential effect of humans on humans by this event. George Howard over here, and he talked about Carolina Bays, potential relationships with that. It's a large group, and it almost has to be, because it's such a diverse subject, requiring a lot of different expertise in order to persuade the scientific community that this is a valid event, that the age that has been suggested, or 12.9, is a reasonable age, that this impact event occurred, that it was at least continental wide and perhaps broader, and that it potentially had some large, very large effects on the biosphere, at least in the Americas, and in terms of the megafaunal extinction, the disappearance of the Clovis culture, and the triggering of the Younger Dryas. I'll talk a little bit take a couple of minutes to talk about, because there's been a discussion on that. But anyway, basically, as the other speakers have mentioned very nicely, there's just a broad range. I don't know what that beeping is. There's a broad range of criteria strongly in support of an impact of 12.9 that of at least North American continental proportions. It's at least about 10. At least 10 distinctive criteria in support of this. It's not a single criteria. I won't go over what those criteria that we nicely presented this morning. The addition of the nanodiamond is just the last few. I would say that assemblage that Alan in particular described, and Luann supported, of course, with the fullerenes and the helium-3 data and so forth, and the evidence for wildfire. That itself is very strong evidence that there was a major impact at 12.9 over North America. And just in the last few weeks, well after the submission of these abstracts for this conference, with the discovery of the nanodiamonds by the material science people at UC Santa Barbara, in particular a person, Chris Mercer, who's a material scientist using the TEM, was a very nice discovery that strongly reinforces the already strong evidence for an impact at 12.9. And it's very hard. I think it's going to be very hard for the skeptics, and there'll be a lot of skeptics for this, as there should be. It's a big discovery that there was an impact of this proportion, and it's going to be very hard for the skeptics, I think, to take this range of evidence. Where there was evidence of major melting of the carbon at very high temperatures, with a glass-like carbon, as Alan said, it's in all of these sections, a hallmark of this YDB layer. And now the addition of the diamonds requiring substantially high pressures, it's very hard to argue that those kinds of materials can be produced by normal earthly processes. So that I would add that. I would also add the increasing evidence of the wildfire that Luann talked about. There's a whole range of evidences, of course, of extensive wildfire at the time of this event over North America. Just simply charcoal, just the simple evidence of charcoal in most of these layers is itself strong, compelling evidence of extensive wildfire. But there's a lot more than that, as already described. But the one thing that hasn't been mentioned so far is the is the ice core evidence. And Paul Majewski has joined this group and is very interested and active in it. And when you look at the Greenland ice core evidence, to make a long story short, there is strong evidence of a massive biosphere burning event at 12.9 thousand years ago at the onset of the Younger Dryas cooling. And it's in the form of the most robust ammonium and nitrate peaks in the last 110,000 years in the Greenland ice core. And that will be described in my talk tomorrow, representing Paul Majewski's input to this. So we have a lot of parallel evidence of this of the wildfire, the massive biomass burning associated with this event over North America. So the other thing I'll just mention is the Younger Dryas cooling, because that's something that I've worked on the Younger Dryas for probably 3 decades or more. This event also coincides with an abrupt cooling into the so-called Younger Dryas at 12.9. It's already been well known to be dated at 12.9. That's the established age of the onset of the Younger Dryas, for instance, from the Greenland ice cores. And the Younger Dryas cooling, which I'll talk about tomorrow with my collaborators, is we suggest now was triggered by this extraterrestrial impact, that the abrupt cooling that led to the onset of the Younger Dryas cooling actually was the result of this event, and that in a nutshell, this cooling would not have occurred. This major cooling during the last deglacial would not have occurred if this extraterrestrial impact had in fact not occurred. That is the hypothesis that we are proposing, and it's consistent with a wide range of evidence. When you look at the evidence already out there in terms of the arguments that are around the triggering mechanism for the Younger Dryas, and then you look at the evidence that has been assembled by the paleoceanographic climate community, there's an awful lot of consistency in the data that's already there in support of the Younger Dryas cooling as a result of an extraterrestrial impact. I'll just leave it at that.
Okay, why don't we open up for questions? Sid?
Hi, Sid Burke from Science News. I have a quick question about if you could describe how quickly the onset of the Younger Dryas occurred and if you can describe how quickly the onset of the Younger Dryas occurred and how the temperature dip at that time, and also just to follow up, is there any oral tradition among North American peoples or tribes that has any sort of possible,
Well, okay, I can say
reporting of
something.
this?
I can say something about the first question. I don't know. Rick on the second. Or Douglas. Yes, the Younger Dryas was a very abrupt cooling. It's well established that it occurred in the order of decades. That's all. Just the cooling was very large over Greenland. It was 8 to 10 degrees centigrade drop in temperature, a sudden drop in temperature. In the marine record of Santa Barbara Basin, which is a very high resolution record that I've studied for many years with my colleagues, the temperature there drop there is 4 degrees centigrade, which is pretty substantial. This should not have occurred, as I said. It's occurring during when precession, when the orbital forcing is towards warming. It's considered an anomalous event. It basically should not have occurred. There's no other. If you look at all the deglacials over the last 700 to a million years, 700,000 years, all the major deglacials, none of them show any evidence as yet. Anyway, no evidence yet of anything like a Younger Dryas cooling during the deglaciation. So I think it's pretty well recognized that the Younger Dryas is a anomalous event. It's been in some body brokers called it a freak event, and I think that's fair. That's a fair term. It's a freak event. And so why is it a freak event? We argue it's because it's due to a freak occurrence of an extraterrestrial impact. Now, in terms of the forcing for the Younger Dryas, there are as in the talk tomorrow, there's a short-term forcing, and In other words, it's a big hammer, if you like, the big hammer of an extraterrestrial impact, creating a lot of particulates in the atmosphere for a few years at least, which is going to draw down solar radiation. There are other mechanisms of drawing down solar radiation. There's a whole range of them. So I think this is actually an interesting event in the sense that clearly there is a major climatic effect of resulting from this event, if you accept that there was an extraterrestrial impact. So there are short term, and I think that when you look at the total record in the late Quaternary and try to think about all of the climate changes that are occurring, I would suggest that it's the combination of the short term impact related cooling in association remarkably with a major change in ocean circulation. In other words, a turn-off, if you like, a shutdown of the oceanic overturning, or if you like, the oceanic conveyor, whatever you like to call it. That occurred, and that was crucial because otherwise the Younger Dryas would not have lasted 1,200 years. That provided the inertia for a long-term cooling, which we call the Younger Dryas, about over 1,000 years. If there had not been a turn-off of the ocean, a major change in oceanic circulation, I don't think we would have had a long Younger Dryas. Would have been just perhaps just a short climatic perturbation result of the impact. So why did we have a change in ocean circulation? Because the impact event destabilizes at least the edges of the Laurentide ice sheet, and that provided the meltwater and the low salinity surface waters that shut down the oceanic conveyor, and all that happened in just decades, very abruptly.
Second question was about the human record.
Yeah.
I think Alan probably answered that best.
Doug, do you want to add anything to that at the moment?
So you can talk about the mythology aspect. I think you've written some things about that.
Okay. Yeah, there are a lot of cultural stories. It's hard to put them into context and say, of course, that they apply to what event. Impact events do occur, small and large. But what is known that cultural traditions based on people in the Middle East can go back many, many thousands of years, and the stories get passed on pretty much unchanged. The Native Americans have a long history of that being the way that they communicate their history, and so the feeling is that at least parts of whatever happened in the past are being brought forward. Have they been changed? Absolutely. But when you look at the stories, there are remarkably similar stories, not just in North America, but around the world, and they basically follow a similar pattern. That the Great Spirit or the Creator or God, whoever, warned the people that a disaster was coming. Almost none of them listened, but a few did. They took some kind of action to protect themselves. Not long afterwards, and it varies from the stories, either stones, fire, ice, or clouds, or water fell from the sky and wiped out almost all the people and almost all the animals, and the survivors went on to repopulate the earth. Well, our theory, and we've looked at a lot of those stories, our theory is that can't be coincidental. Native people today, when they have a normal flood where a river runs over its banks, they don't generally say everybody in the world died and all the animals perished. So clearly something catastrophic happened. Whether it was from this event, we can't say, but the pattern fits. What they describe seems remarkably like the evidence that we find in the field. There would have been fire from the sky, there would have been flooding, it would have been going in perhaps all directions from the ice sheet. It would have been an extraordinarily unpleasant time for people and animals. So yes, I think the cultural traditions have some shred of that truth in them. It's plausible to say that. Can we prove it? No.
Buzz?
For Trouw, which is a tech newspaper in the Netherlands, and The Economist in London. I'm intrigued by the Belgian find, and also West's last answer.
Sorry, I can't hear you.
Okay, I'm intrigued by the Belgian find, and also if it's true that this has been recorded in myth, then it's in Middle Eastern myth or stories. So if this black mat is everywhere in North America and it's in Belgium, why is there no record of it in England or in Sweden or anywhere else? Surely there must have been published data of boreholes in those countries.
Well, actually, we think it's likely that there is evidence. We've only looked at one site so far, but there is what seems to be an analog to the black mat that's well known throughout Germany and Poland, even into Italy, and it's called the Usolo sand. There's a charcoal layer at the top of that. And while the origin of it is in dispute, it looks remarkably like the charcoal-rich layer that we find across North America. At the Belgium site, we have found microspherules, but while we have no idea whether the event was as catastrophic in Europe as it was here, as we just haven't looked, it seems likely that the effects would have been felt throughout the Northern Hemisphere. But what we know about is North America. We just have one site there. But we think it's likely that there are other sites in Europe. If there's one, there are more likely others.
There have been finds of the carbon spherules in Germany, and they're very similar to the ones we see, probably the same thing. They also contain nanodiamonds. So I think that evidence is just about to be found all over Europe.
So the fact that we are now talking about North America, is that because it was an event that happened over North America and spilled over into other areas of the world? Or is it just
Two
we
gentlemen's
have
name tags are
examined the
flipped.
evidence now and that maybe it was
Firestone in the west.
pretty much a global event as far as the Northern Hemisphere is concerned?
As far as the shock wave from the event, it was most intense in North America. It's unlikely that the shock wave was sufficient to do great damage in Europe. The things we find in Europe are the things that got thrown up above the atmosphere, and they came down presumably all over the world. So there would be a layer of dust and debris that would be at least over the entire Northern Hemisphere and probably even into the Southern Hemisphere.
So there's no charcoal layer in Belgium?
Well,
for
there
instance,
may have been
Belgian
fires
scientists.
in Europe. It's possible because when these things blow up, hot material can come down far away and establish fires. But the major damage, if you're within 100 kilometers of the initial event, you're incinerated. If you're within 1,000 kilometers or so, you're just cooked. And if you're within the coastal boundaries of North America, you're swept away by the tremendous wind and shockwave of debris that comes out of this thing. But if you're across the ocean, you just have things falling from the sky periodically. It's less destructive.
I think that's a good question, and there's far more questions coming out of this than answers at this point. I mean, it's opened up a lot of questions that we hope will be that this initial study will encourage by multiple workers in the future, and the evidence, at least in my understanding, the evidence in Europe is that there tends to be a response, at least in the high latitudes of northern Europe. How far this extends southwards is a big question, but I see that. But basically, this study is focused primarily in North America, and the reason for that is that that's where much of the data has been accumulated, and for the study, and we have especially focused in on and trying to understand the North American situation, but that does not, of course, exclude the potential that it has wider effects. It's just that we're focusing on where the best data exists.
Hi, Betsy Mason from Contra Costa Times in California. Sorry, Betsy Mason from the Contra Costa Times in California. Are there other explanations for the onset of the Younger Dryas cooling that seem at all plausible to you that people have favored before this?
Oh yes, in fact I was involved in some of those studies myself beginning 32 years ago, and that was the study that there's a lot of debate on this at this moment about the triggering of the Younger Dryas. You may be aware of that or you may not be, but it just has happened really in the last year, as it turned out. But until the last year, before this debate occurred in the paleoceanographic community, or began to occur in the paleoceanographic community that I belong to. The generally accepted hypothesis for the onset of the Younger Dryas cooling was that there was a plumbing change, basically a plumbing change of the freshwater outlets from North America beginning at 12.9 thousand years ago. In other words, there was a switch off of the fresh water, the overflow water from Lake Agassiz, the meltwater from the Laurentide ice sheet from the southern route into the Gulf of Mexico, which at 12.9, in other words, that water went southwards through into the Gulf of Mexico until 12.9 thousand years ago, and then exactly and abruptly at 12.9, there was a sudden switch off of that water, and that went, in terms of the accepted or the wisdom, if you like, of the last 20 years, that water went east through the St. Lawrence Seaway into the North Atlantic, and that suddenly delivered the fresh water that actually led to the freshwater cap, if you like, on North Atlantic, that then turned off the oceanic conveyor. And that is well illustrated, for instance, in the Al Gore movie. If you look at the Al Gore movie, that particular part of the movie actually is really based on what happened at the onset of the Younger Dryas. But there's been a lot of debate in the community for years as to where the fresh water went. I mean, there's Peltier's work in the Arctic. This is what I'll talk about tomorrow, my talk. Peltier says, no, the water had to go to the Arctic. And John Andrews will say, no, it went out the Hudson Strait. Or Ted Moore will say, no, it came from the breakup of the ice shelves in the Arctic and in the Fram Strait. Even the Europeans see it actually at 12.9 in the Barents Sea, Northern Europe. There's actually evidence of melting, of sudden melting at the onset of the Younger Dryas in the Barents Sea, Northern Europe. Then you have, of course, the classic acceptance has been which was championed by Wally Broker, is the flow of water through the St. Lawrence Seaway into the North Atlantic. Well, as far as I'm concerned, with the impact hypothesis is consistent with all that data. Basically, the impact hypothesis provides the meltwater around the entire periphery of the Laurentide ice sheet. So basically, this is in support of much of the data that's already in the literature. So, and there's been debate the last year about just where that water is going. And so that, in a nutshell, that's what the debate has been. Really, where was the water where was the meltwater going? And it wasn't really a meltwater or freshwater surge, or like, that actually turned off the oceanic overturning, ocean overturning, or conveyor, whatever you like to call it, and then led to the Younger Dryas cooling.
Was there another mechanism proposed for the switch off, and to see how the switching the flow of water could have caused? That was actually proposed by myself and Nick Shackleton in a paper in Science published in. Dick Kerr's unfortunately not here because he reported on it at that time. It was 1975, and Nick Shackleton and I discovered this switch in the water from the south to the east, if you like. And the reason for that was that there was a critical meltback. There was a critical meltback of the southern edge of the Laurentide ice sheet that opened up the conduits to the east, and that was basically the sort of accepted hypothesis for the opening of that outlet. Critical phase of the melting of the ice sheet.
Why don't we see if there are any questions now from the telephone participants. We have two phones. One I know someone's on, and I'm not sure about the other one. So let's first go with who we know. Dagmar, are you there? Do you have any questions? Okay. And do we have anyone on the call-in line to the press conference? I guess not. Okay. Do we have any other questions here from?
So why is this the first we've heard of this?
This is the first we've had enough information together from enough people. You saw that collaboration. A lot of the members of this collaboration have never met each other yet. This is a collaboration that's occurred over the internet over a number of years. And it's only in the last year or two that all of the disparate evidence started coming together into a common consensus as to what this all means. We knew there was an impact in Michigan, or we thought there was 8 years ago. But it wasn't until Alan started gathering data from all these other sites, maybe 2 or 3 years ago, that we really saw the picture come together. And now is the time to start the discussion of what this means. Like Alan mentioned, this is related to a lot of things that are important to us, and it's important that we get this right. So we're just coming out with it now. The next thing you'll hear will probably be all of the criticism of our colleagues who haven't heard it yet, because if you haven't heard this, it's pretty surprising.
So it sounds like this is something that maybe some of you had suspected for a while?
8 years.
And so once you found evidence that looked like it might be from an impact in Michigan, did you then start looking for similar evidence in other places?
Well, there was a hiatus in our research. My colleague Bill Topping wasn't able to go out and see other sites, but he had gathered this evidence and shared it with me 8 years ago, and we did initial prompt gamma activation analysis of the materials that he found, determined that indeed there were unusual things there. And then it stopped at that point. We wrote a short article in the Mammoth Trumpet, which I'm sure you all read, and then it kind of stopped there. And there were some problems with our arguments. We didn't have enough information, and you could be dismissed as just a unique site that had some inexplicable information. I should mention at that site there are 2 microspherules per gram of sediment. That's an enormous number of microspherules. We have more microspherules in our collection than the rest of the world has collected in all of their research, I believe. So we really have found the mother lode of impact material, maybe because it's so new. And then it was about 3 years ago that it picked up again when Alan got involved, and then all my other colleagues here got involved, and they all contributed important pieces to the arguments and redundant pieces, so we are quite sure there was an impact. When you start going into, did it kill the mammoths, did it cause the Younger Dryas? Well, those are implications of our results. It's a little harder to prove that that happened. Nobody was there recording it at the time. On the other hand, if you follow what we all learned in undergraduate school, in chemistry at least, I learned Occam's razor, that if all these things happened at the same time, they're related. It's most likely the simplest solution. So we now have the confidence to really go forward with this and say, yes, we really strongly believe this. And we hope that your sharing it with people will spread the comment and help us really convince other people that this is an important, serious subject to be studied.
One thing on the human impact too, I think we've been maybe overrepresented the mammoth side of the story, but not the people side. And that's really the 2 fellows sitting back here, John and Doug, have really looked at that. They both looked at what kind of effect this would have on culture. So maybe, Doug, would you want to say a little something towards that? You know, what happened to the people? We know the mammoths were gone.
Okay. Well, I'll be talking about this and kind of coming to grips with this event. I mean, as an archaeologist thinking about prehistoric culture and cultural change and human ecology, being confronted with the idea that there was this major event at this time where we see clearly in the records been known that there are major shifts in human adaptations at this time that have been known in the archaeological record. And then going in, what we've tried to do is go in and look at the archaeological record as it exists today, which was not designed. It was not the data gathered was not designed to test the specific question. So we're coming in and looking at the records across North America with the idea that perhaps this event was the most severe up in the Great Lakes area and over into the east, and then thinking about the most immediate effects versus the cascading ecological effects of what this would have, what kind of what this would have meant for the human population. What it would, what kind of hypotheses can we develop to look at, to address with the archaeological record? Because I think the archaeological record and archaeology will play a vital role in trying to understand the consequences of this. So what I'll be talking about tomorrow is we've done this, and this is a massive project, and this is a huge amount of data that's been generated over 100 years of varying degrees, varying quality. But what it seems is that there are certainly stratigraphic breaks in the archaeological record. Alan West mentioned Blackwater Draw. Well, Blackwater Draw has a Clovis occupation, then you have this black layer with ET impact materials. There's also a Folsom occupation at that site, but it's 500 years later. So there's a 500-year break there. On the Channel Islands, where both John and I have done some work, there's no site there that has both Clovis and post-Clovis contemporary records in the same spot, but there is clear evidence for a Clovis age burial that John could probably speak a little bit to. And then it appears this layer. And then the next occupation that we see on the Channel Islands is about 800 years later at a site called Daisy Cave. It's also true in the east. At a site called Shawnee Minisink, there's a Clovis age occupation. We haven't looked for this black mat there, but there's also a break. 1,000 years later, you get late Paleo-Indian peoples coming into that location. So, and then there's a variety of other evidence. If you look at the distribution of projectile points across North America, these very distinctive Clovis points, they're pretty much the same from coast to coast. And then the post-Clovis assemblages of projectile points, which our archaeologists have looked at, that look like they're related. They have fluted bases. In the west, they're called Folsom, and there are a variety of other different types of points in the east. So there looks like there's a big kind of diversification in the east in these projectile point traditions. And there's also many fewer of them. Not that this is a very good tracer for population reduction, but there's a big reduction in the number of those kinds of points in the east. And there's a poster about that Al Goodyear will be presenting in one area in our talk. We'll be talking about that reduction. And there also seems to be, there are very few definitive post-Clovis sites in the east. It's very difficult. The one site that we can identify that has clear stratigraphy, a nice suite of radiocarbon dates, is in northern Alabama. It's called Dust Cave. I'll talk about that. And there's a major gap between Clovis and the occupation at that location, about 500 years. There are many more sites in the west of Folsom age, but there looks like there are people there. Perhaps this is like a refugia for people in the west. There seem to be sites that date to immediately after, although it is a statistical possibility that there is a gap in those records as well. And then I'll talk more about that tomorrow in my presentation.
And also Terry Jones is giving a poster on suggesting that tomorrow also.
So the fact that there is this gap is not new. Just this explanation for the gap is new.
Well, people haven't thought about, people, the types of, again, my colleague David Anderson, who's, he's really the archaeologist who's done a great deal of work in the East, and he's a co-author on the paper that I'll give tomorrow. We're kind of coming to grips with this and saying, we haven't looked at these records in the same kind of a way. And people have talked about in the East, why are there no, post-Clovis fluted, stratigraphic sites? Why aren't they living in caves? Where are the people? 1,000 years later, 800 to 1,000 years later, you get sites all over eastern North America. Nice, clear, very distinctive habitation sites.
And this is when you have that diversification.
Well, there's a diversification that seems to happen earlier in those points, but we don't know exactly what those fluted projectile points in the east. Not one of them comes from a stratigraphic archaeological context. There's one that occurs in Dust Cave at the base of it, but it's probably reworked into some slightly later materials.
Okay.
So the records are basically a mess.
Do we have another question from Boss?
Yes, to follow up on that, is it conceivable just that at the time of the impact, just everybody, every human being in North America died, and the culture was replaced by newcomers from Asia, the second immigration, or is that unlikely? And if everyone died, or almost everyone, how many people are we talking about? Is it in 100,000, or in 10,000, or in a million?
Maybe John said
When you look at the archaeological sites in Beringia, you know, in Alaska and Siberia, they also had, there's a gap that occurs right around 12.9, you know, going on. So they have, it looks like it's the same gap up there that you see in North America. The other thing I'll mention is that I've done a little work with mitochondrial DNA of California Indians in particular, and what we find is that there appears to be a greater genetic diversity in the West, you know, which may indicate greater survival, you know, of people in the West than what you find in the rest of North America.
So I guess the answer to your question is no, I don't think all people in North America were wiped out. But it's at least conceivable that that there was a heavy impact in the east and to the north that certainly reduced and fragmented populations, and then with perhaps refugia in the west. And I think the archaeological record, the way that it stands now, it would be consistent with that idea. But then you have to start thinking about colonization episodes, recolonization of areas that were devastated. And some obvious areas would be from the south, potentially. We don't know what the effects of this were to the south. You definitely have extinctions in Mesoamerica, in Mexico, of megafauna. So, you know, what's going on here and also in South America, but you could have refugia to, you know, farther to the south. Or re-entry from Asia, again, as you mentioned. There's a major bottleneck in bison populations at this time. That's one of the animals that actually makes it. There's ancient DNA evidence that I'll talk a little bit about tomorrow. And we have a poster on megafaunal extinctions too. And I think that bison story may be telling us something about the human story, because at least in the plains, the animals that they're tracking right in the post-Clovis period are bison. And there seems to be a reduction in, you know, again, in their populations at that time.
How many people lived in North America before the impact?
Exactly. Okay, I think now it's 11, so I think it's about time to stop. Just want to check one more time. Is there anyone on the press conference call in line? Okay, so you're welcome to come and ask more questions after. And I just also wanted to point out there's a handout in the back of the paper that Dr. Firestone was showing on the screen.
Oh, thank you. I also have a press release from the University of Oregon about some of the cultural elements back there.
Okay. All right, well, thank you all for being here, and we'll have another press conference at 2 o'clock.